Okay, guys, so today we're looking at graphing the sine and cosine curves, and we're going to finally be looking at changing the period. So if you remember, when we were graphing all of these curves up until now, we've left the period at 2 pi. So in other words, the coefficient in front of the theta or x was always just 1. So I'm looking at, oh, hold on. I'm looking at this number right here was always 1. So now, obviously, it's not 1. As you can see, I've got a bunch of different ones right on my screen here. And number 1, that coefficient there is a 2. And number 2, that coefficient is actually a 1/3, right? So you can think of that as 1/3 times theta. Number 3, the coefficient's 4. And then 4 would be a 1/4 again. Okay, so that coefficient there is actually b. So if you recall, this is what we're graphing. Y equals a times sine of bx, okay, or cosine. So a is what we've been focusing on the last couple days. That's our amplitude. So for today, we're going to leave a as 1. So if you look at any of these out in front of the sine or cosine, there's no number there. So that's really just a coefficient of 1. So we're going to leave the amplitude alone for today. Tomorrow, we'll mix them together. We'll do changes in amplitude and changes in period. Okay, so just to refresh your memory, the period is how long it takes for the curve to complete one full cycle. So a real quick sketch, if we were looking at sine, remember sine always starts at the origin and then it went up, went down, and then it came back. Okay, let me just make that a little longer. Oh geez, now I really messed it up. Hold on. Trying to make it line up there. Close enough. Okay. So that's one full cycle that you see there. Okay, and then it just kept going and going and going forever in both directions. But that's what we refer to as one period, okay? And so that every day up until today has always happened in 2 pi radians. Okay, now it's going to change. Maybe it does the full cycle in half as much time. So maybe this is now just pi instead of 2 pi. Maybe we stretch it out, right? Maybe it takes a lot longer to do the whole thing. Maybe it goes all the way out to 4 pi. Okay, so it's kind of like an accordion. We're going to squish it together and we're going to kind of pull it wider. So let me teach you how to figure out what it is. First, let's erase all this stuff that we don't need. Okay, so I think I already explained how to find b. It's just the coefficient of whatever is in front of theta there. Or it could be an x, so not a big deal if it's an x. And now, it would be so easy if that was just the period. Well, it's not exactly. So your period is equal to 2 pi divided by whatever b is. Okay, so b is the number that you see right in front of the theta. So in the case of number 1, b is 2. So if I want to figure out the period for number 1, I'm going to plug in 2 for b. So the period is going to be equal to 2 pi divided by b, which in this case is 2. So that means the period is just pi. Okay, so what does that mean? That means when I go to graph that cosine curve, it's going to complete one full cycle in pi radians. So if I look right here, pi radians is right here. So this isn't part of my graph. I'm just drawing this so you can see one full cycle is going to happen between here and here. So in between those two lines, I'm going to have one full cycle of cosine. All right. So the important parts that you need to think about are, there's really 4 pieces of that graph that I need. Its starting point, where it crosses the x-axis the first time, where it bottoms out, where it comes back up and hits the x-axis, and then back up to where it finishes. So I need kind of all of those numbers. Now, luckily, if my period is pi, I basically need to break it up into fourths, because I know I'm starting at 0, but then it's hard to describe. Maybe it'll be better as we kind of graph it. This one's nice and easy, and the numbers are already given to us, so I already have all the quarter points, I call them. All right, so they're already there. Sometimes those won't be labeled for you, but here we've got them. Okay, so let's do one out, and then maybe it'll be easier for me to explain. So let me erase some of these things that we don't need. Okay, and now let's get to the graph. So where do you start? Well, the starting point depends on if you're dealing with sine or cosine. Since this one is a cosine graph, remember that those do not start at the origin. That's going to go ahead and start up at 1, okay? Tomorrow when we change the amplitude, I might be starting at 2 or 3 or 5 or 17. It just depends what that coefficient in front of the cosine is. So in this case, it's just a 1. So I'm going to start my whole graph at 1. Okay, and then the next point, right, I'm going to come down from cosine. It's going to hit the x-axis right there. I'm going to bottom out at -1. I'm going to come back up and hit the x-axis at 3 pi over 4, and then I'm going to top it out back at 1 at pi. So see how I've done one complete cycle of cosine between 0 and pi, because pi is my period. Okay, so I've done one full cycle. And then as you know from previous days, that this cycle just continues, so it just keeps going forever in both directions. So that one's just going to go this way. Okay, so that's what that one's going to look like. Okay, so now let's go ahead and try sine. Let's try this number 2. So I'm going to erase all of this. Yeah, okay, let's just erase it all, because I want to slide this over anyway. Still haven't figured out how to erase everything all at once. I'm sure there's a way. All right, so let's slide this over and look at number 2. Okay, so first I need to figure out the period. So remember that the period is equal to 2 pi divided by whatever b is. So in this case, b is 1/3. Do you see that? Do you see how b is 1/3? Because couldn't I rewrite this as sine 1/3 and then theta? Isn't that the same thing? Okay, so b is 1/3. So I want to do p equals 2 pi. What happens when you divide by a fraction? Isn't that the same thing as multiplying by the reciprocal, right? Keep, change, flip. So I'm really going to do 2 pi times 3. So the period actually comes out to be 6 pi. So that means it's going to take 6 pi for this to complete one cycle. Okay, and what I need to do is I need to figure out those quarter points. All right, so the easiest way to do it, in my opinion, just take your period to find the first quarter point, just divide it in 2, right? So that'll get me my halfway point. So my quarter points, let's call them. So I'm going to take the period, whatever it is, and divide by 2. Okay. Divide period by 2. So in this case, that would be 3 pi. So far I have 2 important points on my graph, 6 pi and 3 pi. I'm actually going to, let's get fancy. Let's highlight. I think I can do this. Okay, so 6 pi is an important number, and so is 3 pi. So something important is happening on my graph. Actually, hold on. Let me kind of want to make them smaller. Okay. Those are 2 important points on my graph. The other 2 points are halfway in between those 2. Okay. And so if I start at 0, well, 0 is another important point, right? Because the whole thing's going to start there. So to get my next 2 quarter points, I need to go halfway in between 0 and 3 pi, and halfway in between 3 pi and 6. So this isn't as convenient as it was on the last graph, because the last graph already had all of those values for me. This one doesn't. Okay, I don't necessarily need you to fill them in, but you should be able to tell me what they are. So if I'm looking between 0 and 3 pi, what is halfway in between 0 and 3 pi? Wouldn't it be, well, what's halfway between 0 and 3? Isn't it 1.5? So 1.5 pi would be my next quarter point. So let's see. I'm going to try and squeeze that in there. So where would 1.5 pi be? It would be right there. Oh, right there. Okay, so that's 1.5 pi, or 1.5 pi written as a fraction. Isn't that just 3 pi over 2? Which makes sense, right? Didn't I literally just take 3 pi and divide it by 2? Okay, and now I need to do the same thing. There's going to be a point right here. That's going to be my next quarter point. So it's halfway in between 3 pi and 6 pi. Well, couldn't I just average 3 pi and 6 pi together, right? So 3 pi plus 6 pi is 9 pi divided by 2. 9 pi over 2. Oops, my pi got a little messed up there. Okay, so those are the important points. So I'm just going to put, let me highlight those also. It's working, there we go. Okay, so those are all my points on this graph where something important is going to happen. Okay, I hope that kind of makes sense. Now let's go ahead and actually make the graph. So let's choose, let's do green, and we will go ahead and graph. So now I go back to the original. I see that it's sine, so sine starts at the origin. So I'm going to start at the origin, so that's my first important. Why is this highlighting? I meant pen. Pen, there we go. Okay, so I'm going to start at the origin. Now, my amplitude is 1, so at my first important point after 0, I'm going to go up to +1. So right there, I'm at +1. Let's make that a little bit bigger. At my next important point, which in this case is 3 pi, I'm back down to 0. At my next important point, which is the 9 pi over 2, now I'm bottoming out down to -1. And then at 6 pi, my last important point, I'm back to 0. So there's my graph. Okay, and do you see how one full cycle happened in 6 pi? Okay, these are a little weird at first. It's okay, I get it. We're gonna keep practicing. Let's go ahead and erase these. Someone knows how to erase it all at once. Let me know, because there's not any obvious. Maybe if I like double tap. No. Okay. Let's try 3. All right. Okay, let's stick with red. I like red. Okay. Excuse me. So we need to find the period. So the period is equal to 2 pi over b. What's b in this case? If you just said 4, you are correct. It is whatever the coefficient is in front of that theta or x or whatever it is. So in this case, it's a 4. So the period is equal to 2 pi over 4, which if I reduce that gets me pi over 2. Okay, so that means that this sine curve completes one whole cycle in pi over 2. So that's my first important point. Okay, ooh, this one's gonna get a little narrow in here. Okay, let's switch to, okay, I was gonna go to highlighter. All right, so I have an important point at pi over 2. I always have an important point at 0. Okay, so there's my first 2 important points. Okay, to get my next quarter point, I want halfway in between 0 and pi over 2. So luckily they already have it for me. Halfway in between those two would be pi over 4. Okay, now to get my next quarter points, I have to go halfway in between each of these. Okay, so what's halfway in between 0 and pi over 4? You might be able to do it in your head. If you're not, just add 0 and pi over 4 together, which obviously is just pi over 4, and then divide it by 2. Remember that dividing by 2 is the same thing as multiplying by a half. So you end up getting, this is going to be kind of squished in here, but there's another important point in between those two, and it's going to be pi over 8. Okay, so let me squish in pi over 8. Okay, for that first quarter point right there. Then I need another quarter point in between the pi over 4 and the pi over 2. So again, your best bet is to just add them together and divide by 2. So let's do the math down here. Pi over 4 plus pi over 2. Well, remember to add fractions together, you need common denominators. So let's multiply this guy by 2 over 2. So I'm really adding pi over 4 plus 2 pi over 4, or 3 pi over 4. But now don't forget that you need, that's me adding them together, but now I need to divide by 2 or multiply by a half. Okay, so multiply that by a half and I get 3 pi over 8. I know you're thinking, oh my goodness, Mrs. Sadie, I will never ever be able to do this. Yes, you will. You just gotta, the more that you try, you'll get the hang of it real fast. You'll also notice that the same numbers keep popping up, so you don't have to redo all this work every time. Because you'll see, when we get to the back of the page, we'll probably see that some of these repeat. So you don't have to go through and find all these quarter points again. Anyway, 3 pi over 8 was that one. Oh, well, that's okay. So that's 3 pi over 8. Okay, now let's graph. Oh, let's switch to green. Okay, so this is sine. So that means I am going to start at the origin. So my first dot is just at 0. My first quarter point happens real quick. That's where I'm going to go up to 1. My next quarter point, I'm back to 0. The next one, I'm at -1, and the next one, I'm back at 0. So as you can see, this one happens really quick. So it's boom, boom, boom. Everything's all squished in there. Okay. Now, if you're worried about these points here, I do want you to be able to find them. On a worksheet like this, where the values are already given to you, if you don't find them, it's not the end of the world. Like I could have made this graph without figuring out that this number right here happened at pi over 8, and this one happened at 3 pi over 8. You get what I'm saying? Like, you know where on the graph this happens. I do want you to be able to find those values though, because what happens when you're not given a scale at all? You're just given a blank graph, right? With none of these values, right? So imagine that all of these values right here weren't given to you. If you didn't have those and it was just a blank grid and you were just given this equation up here, right? If you had to fill in all those pieces, you need to know where those numbers go and what they are. You can't just make them up. Okay, so I know it seems a little tedious, but trust me, once you do a bunch of them, it does get easier. Okay, so let's erase all this. Do you like how I pulled out those rectangles there? Look at me being like an expert here. Just don't know how to erase everything at once. Okay, so let's do another one together. Let's see what we have on the other side. Oh, I don't know. So yeah, let's see. Some of them. Yeah, okay. So see how like number 1 and number 9 they're both going to have the same period. So you don't have to go through and find all the quarter points again. You already have them, right? Same thing for, let's see, who's got number 4 has a 1/4. I saw one over here too with a 1/4, right? Number 5 has 1/4. So you already know those numbers. You don't have to go back and find them. Okay, so let's do one that we haven't done. We haven't done one like number 8 that has the pi over 2. Okay, so let's do number 8, and then I'll let you do the rest of them. Especially now, though, I mean, you'll have most of the numbers. So the rest of the problem should go pretty quickly because I think we've done out most of the quarter points for all the other ones. Okay, so let's try number 8, and then I'll stop talking so you can actually try them. Okay, so let's get started here. P equals 2 pi over B. B in this case is what? Did you say a half? You're so good. You're right. So when I go to simplify that, remember keep, change, flip. That means that the period is actually, if you said 4 pi, you are correct. If you said 1 pi, that would be 2 pi divided by 2 would be 1 pi, right? 2 pi divided by a half, you really have to multiply by the reciprocal. So that's a very common mistake. I know you see 2 and a half and you just, 1 just pops out in your head. But if you're dividing by a half, you got to remember to do that multiplication. All right, anyway, let me shut up. So period is 4 pi. Hey, this one's actually awesome because the numbers are super easy. So check this out. 4 pi, that's my one full cycle is going to happen between 0 and 4 pi, right? And then my quarter points, oh my goodness, if the whole thing happens in 4 pi, that means my first quarter point is at 2 pi. I say first, it's not really the first because the first one's really right here. I mean the first one that I find, right? So then halfway in between 2 pi and 0 is pi, and then you have another quarter point right here. So this one, my gosh, they were so easy. So sometimes it works out very nice like that, and it's not, you know, a horrendous deal. So now let's go ahead and graph. Let's graph in red. Why not? And you know what? I'm actually going to leave it on highlighter. No, I'm not. Okay. So let's see. Oh, again, we're doing sine. Oh, I guess I did leave it on. There we go. Okay. So we're doing sine. Sine starts at 0. My amplitude is 1 here, so I'm just going to go up to 1, come back and hit 0, down to -1, back up to 0. So there is one full cycle right there. Oops. And then I would just keep going forever in either direction. Okay, so hopefully not too bad. I know these take a little while to get used to. So tomorrow we're basically practicing the same thing. The only difference is that we're going to incorporate a change in amplitude. But that's pretty simple because now we're just oscillating in between something besides 1 and -1. So maybe we go up to 2 and -2 or 5 and -5, whatever it is. Okay, so that's the only thing that we're going to add on tomorrow. So you get more practice with that. Okay, so try the rest of these. I think I left the answers right there. So please do try it and then check your answers. Don't just copy the key. That's not going to help you with anything. All right, good luck.